Hello, it's David. So you might have seen some of my previous videos where I built a 68,000 accelerator for the STE, my STE that I have there. Shipped a few of them. It's all published open source. Have a look on my GitHub. Shipped a few of them off and seen problems basically with STFM boards. Now I don't have an STFM, so debugging it remotely has been very hard until now. What's this? This is not an STE. That's right, this is an STFM board. This is what I've managed to pick up off eBay. So I'm going to have a bit of a look at this and see what we can do with this today. So one of the key things that I obviously need to be able to do is to test my accelerator, which plugs in to the 68,000 socket here. I say socket here, it's not a socket yet, it's just a chip. So I need to somehow get that off and fit some sockets so I can plug my board in. Obviously the keyboard won't fit under that, but this is, I haven't bought a whole unit, just bought the motherboard. I can plug my Falcon STE keyboard in here, come out my own power supply in there, and it should be fine. But first of all, let's have a bit of a look at what I've managed to pick up here. Okay, so I've got my STE keyboard here, and that's got a long extension lead on it to allow me to keep that off the bench, or rather on the other bench. Got a power supply, and I'll use this little Gotek floppy emulator just to give us something to look at if it works. Because remember, TOS1 doesn't show you an Atari logo, there's no memory test or anything like that, so the only way we'll know if it really is doing anything is if we see a desktop. So if we see a desktop, we'll have a chance to look for it. Okay, so fingers crossed, we're all connected here, we're all connected here. The keyboard's got a power LED on it, obviously, so I'll be able to see when that lights. I don't know if I can just squeeze the LED, there we go, squeeze the LED into shot. So fingers crossed, no bangs. LED's on. Don't smell anything. However, I'm not seeing anything on my monitor. So first things first, have the cable the right way around for the disk drive. Is the cable's in. Okay, there. The power supply, I'm unplugged at the wall. Power supply's okay. We got our red light. I wonder if that reset switch is stuck in. Try pulling that reset switch out. Okay, I'm going to plug back in at the wall and see if we get any more luck. Okay, so green light again, and aha! Signs of life. And we've got a desktop. Okay, so it hasn't picked up the floppy disk, but we have keyboard movement. Well, this is using the emulated keys. There we go. So why hasn't it picked up the disk drive? Have I got it plugged in the right way up? So the thing with the Gotek, or rather the thing with the ST, is that the original floppy disk drives were basically mounted, the cable was mounted the other way up. I'm just going to unplug again. The cable was basically mounted the other way up to what you expect from a modern, sorry, dog in the background, mounted the other way up for what you expect from a modern drive. So when you plug in something like your Gotek, you have to flip the cable over, and you can see it's a very short cable. It's putting a lot of strain on it. It's possible that that's not making a good connection. So it doesn't go in this way round, it goes in this way round. And in fact, you can see the notch on the Gotek does coincide with the notch here on the floppy ribbon cable socket. There we go. So that should be okay that way around. Let's try that again. Just going to put the power back in at the wall. Okay, flash floppy dev pack 3.1. Ah! That apparently is what it was. Let's get rid of that G cramp. So that apparently is what it was. Right, so Control A, Alternate A, none of those work because it's TOS 1. So let's have a look manually. Floppy disk, there we go, dev pack. Great. The key thing for today is to try and replace this down here. This is the Motorola MC68000 CPU, and this has to be socketed. Okay, so I've got a couple of options to take this off. Obviously it's through hole. Obviously it's a DIP64 package, 32 pins either side, delicate old board, possibly not in great condition. The chances for this going wrong are quite extreme. I don't have one of those fancy powered, electrically pumped desoldering stations. I have one of these. This is a self-heating desolder pump of the type that you commonly see, manual trigger. This one is self-heating. It's basically a soldering iron with a hollow tip, and it costs about £6. You depress it, you heat it up, you put it on your pin, and it works as a desoldering pump. And that's not bad. That would be okay probably if I was doing, perhaps one of these chips, something like this. Maybe even add a push a ROM size chip. But I am just not convinced that I'm going to get a 68K off safely without damaging the board. The technique I would probably adopt is to introduce extra solder. If we flip the board over here. If I absolutely had to get the chip off intact, the 68,000 that is, so here it is here. These are the two rows of 32. And you can see some of these. In fact, some of the tracks there don't look all that chipper. If I were to look at that, is that a bit of corrosion perhaps? What's going on there? Well, it doesn't seem to be coming off, whatever it is. So it could be actually damage to the solder mask, damage to the tracks themselves. I'm not sure, and there is some here over by the 68,000 socket as well. You can see it along here. So I think with that in mind, looking at the state of the board, knowing that they don't take much to push them over the edge here, I think discretion may very well be the better part of valor on this count today. And I think my trick would probably be to try and cut off as many of the legs as possible and then desolder them one at a time. I know, I'm afraid that it results in the loss of a 68,000 chip to the world. Well, I mean, technically you could solder wires back onto the legs, but that would be somewhat extreme. It does result in the loss of the chip, but this is frankly a rubbish 68,000. This is an 8 megahertz, old, high current. This is not a good chip. There are better chips. The PLCC ones, HC ones are better. If you had an adapter and put an HC PLCC in, it would be more reliable anyway. So I'm not going to be too worried about it. So the technique I shall probably adopt. And I have never done this before either, so this is going to be an adventure for both of us, for all of us. The technique I would probably adopt is to try and get in as many pins as possible, and it may not be possible with some of these packs down here, for example. Get in with the old side snips and try and chop off the legs as safely as possible. Now, whilst I'm doing that, I'll just take a moment to thank the sponsor of this video, PCBWay. PCBWay can provide you with excellent quality boards with a very fast turnaround, but that's not the only string to their bow. They also offer CNC machining, sheet metal fabrication, 3D printing, and injection moulding. So if you're looking to get your circuit boards manufactured, or indeed other projects off the ground, why not have a look at their website? You'll find it linked in the description section of this video. Okay, so I've gone through and snipped everything down this side here, and you can see that this side is now loose. The issue is on the far side, it's a lot harder for me to reach. I've snipped along here where I can reach, I've snipped along here where I can reach, but this resistor pack here is stubbornly in my way. I might try to come in from the top here. That doesn't seem to be working. Could I try and do two in one go? Maybe that way around. Cut really close to the package. Oh, there we go. I don't like that cutting two at a time. I might be damaging the circuit board. So I'm going to try this way around. There we go. Actually, that's really quite effective. There we go. Now I'm really sorry, 68,000 fans, but let's be honest, this is a crap 68,000. Off to the e-waste with you. Okay, so I think what I'm going to do to start with is to put a little bit of flux along some of these pins here. This is just my normal flux paste. We'll see how this goes, and I'm going to try initially with my self-heating solder sucker, and I'm going to try from the top and see whether I can just suck the entire pin out. Now this might be a bit optimistic, but I'm going to give it a go and see how we go. So managed to get one pin out there experimentally. My solder sucker's a bit gummed. Let's try that again. So I'm just going to go over the entire pin, apply a little bit of lateral and fire. Well, it hasn't taken the whole pin out. It's got rid of most of it. Let's try that again. There we go. That's actually sucked up the entire pin. See, I'm just going to examine that a bit more detail to see whether I've caused any damage. Because that solder sucker is quite violent when it discharges. Whether I prefer to heat and pull instead. That's my other option. So I've got my normal chisel tip soldering bit here, and I could try grabbing the pin at the same time as I heat, and then come through and remove the solder later. That might be the safer bet. I think I might try that trick first. Okay, so important lesson so far. If I'm going to do this in the future, cut the legs longer rather than shorter. It makes this process a lot simpler if I've got something I can actually grab onto. that was the ground pin, or a ground pin, and that came out relatively easily. What I don't want to do is to pull too hard, actually. I want to just feel it moving first, because if I put too much pressure on there, there's a very real chance that I lift the entire plated through hole. Wait for it to melt. There we go, just very gentle upward pressure. I think I've probably been guilty of forcing it a bit too much. Give it time to melt. There we go. Okay, so I've gone through most of the pins here now. We've just got these few left here by the resistor pack, which I need to attack from this direction. And there's one. Is that damaged? Don't think so. And then there's one over here that's too small for me to grab, so I might try my big sucker on that one again and just try and pull the whole pin through in one go. And then, well, what you can see is that the holes on that one I tried with the solder sucker, and that's done a good job. But the holes are filled with the old solder here, so I do need to go through now with my solder wick or a solder sucker and try and remove the old solder. Here are the pins that have been removed. I think, to be fair, the chances of me damaging things are far lower this way. This was probably the right decision. Okay, now look, I'm as big a fan of a soldering montage as the next man. In fact, probably more than the next man, given evidence. But this is a desoldering montage. This took me about 7.5 minutes, and I'm just going through unclogging holes with a solder braid. I don't think there's anything you can really learn from this. I got most of them out first time, had to use the sucker on a couple of them. It's really not worth your while. Okay, so we'll just tape this down to start with, just to hold it in place while we anchor the reverse. Flip the board. Okay, so we're going to be working over here. These are the two rows. The tape is on. So let's get a little bit of flux on the corner pins. I'm going to try 290 degrees to start with, and we'll see how well this goes. It could very well be I need to step the temperature up a bit, but I'm really quite nervous about damaging the board. I've come this far. I quite like it to survive. So let's just try and anchor these corners. I'm not very happy with this corner pin here. I had buzzed it out earlier on, but I've added more solder to it, and the solder is all vanishing. It looks absolutely dry. I don't want to put too much on. I think it's wicking through, but some of these pins are a little bit struggling. I think there is a little bit of corrosion there. We're just going to have to see how we go afterwards, I think. Okay, so the pin I was most concerned about was number 32 over here, which we previously established connects to a ROM line over here. So that does seem to be working, but it was sucking an awful lot of solder through. So hopefully it's connected well to the through plating. I'm just going to do a quick continuity test between adjacent pins. I think that's just capacitance. That might be VCC and ground off the top of my head. There you go, that one is ground. and that one's VCC. So yeah, you've got a big old capacitor on that, so that's why that beeped briefly. Just make sure we don't have any inadvertent bridges. We shouldn't get that same capacitance beep on this side because I think VCC and ground are a few rows apart. There they are. A few pins apart, I mean. Okay, good. So we don't have any shorts, so relatively content with that. I suppose I ought to, just for completeness' sake, make sure that we don't have any shorts between VCC and ground. Well, I know we don't. I did just effectively test that with the capacitance. What's it called? The capacitance across the two. So I'm going to go straight across this capacitor line here, and that is showing 77 ohms, which sounds reasonable. So I haven't shorted VCC and ground together, which is the biggest danger. The next trick would be, I think, we should pop our chip in and power it up. So this is the DSTB1 that I shall be putting in later on, but I'm not going to go straight for that. The chip on top here, this is a 16 megahertz capable MC68000 P16, you see there, plastic 16. So I'm going to pop this out of here gently as I can, and we're going to mount it in our newly installed, oh, it's a bit firm on one side or the other, our newly installed socket, and we'll see if we can boot up. There we go, with our new chip, new for this board, and in just stock configuration. So this is a used chip, as in I've used it in other places, so there shouldn't be any problems getting it to align with the turn pin socket. There we go, straight in. Just a little bit of pressure towards me, you saw there. And that's it. In fact, I think I've probably overbent these pins in the past, and they are a bit, if anything, they're a bit loose, I think. Right, so there we go. Let's power her on. Okay, so same setup as before. We've got our PSU in here, it's connected up. We've got our VGA adapter to mono mode set up here. We've got our new chip in down the bottom with it facing the right way, just double check that. Got the keyboard hooked up on the side here, and I haven't plugged in the power supply yet. So I'm going to throw the switch here. I think that's on. And I'm going to plug it in remotely, just in case there's a problem. I can whip it out again quickly. So here we go. Going in now, and nothing's happened. I think I must have guessed incorrectly, so I'm going to throw that switch carefully. Okay, we've got a green light, and our monitor's woken up, and we've got a desktop. Splendid. There we go. So we've got a desktop with no drives. I haven't connected the Gotek. Perfect. Right. Well, I suppose the next step would be to try and put in our the DSTB1. Why not? Okay, so the chip's back mounted in the DSTB1. These are my just tap-off pins from the old from the graphics card project. They have no bearing on this. Now this is actually currently flashed with a firmware that will run, oh, I've got a bent pin there. This is currently flashed with a firmware that will run at 8 megahertz mode by default. This is because I'm debugging the alt-RAM, the STRAM driver at the moment. So this should be a nice starting test. We should just get completely normal behavior. I don't even know whether I'll be able to do anything at all because it's a 512K machine, and until I sort of get some an operating system that understands alt RAM in here, and a few other things. I probably can't do anything at all. Maybe I can, by grounding one of these lines, I can get it into 16 MHz mode. At least maybe I can measure that. So we've got something to see for our work. But all we're hoping to get at the moment is this to boot up so that I can then actually start development on it. So we're looking for pin alignment here. It feels like there's resistance on this side's okay. There we go. We're in. There we go. Right. Quick inspection. This side's fine. Your side, yep. Can't see any problems there. I think that's fine. Okay, here we go then. Let's try again. Okay, so I'm going to point straight at the screen this time, so you've got the full dramatic effect. And I'll keep my eyes open for smoke. Same thing again. I'm going to plug the power supply in remotely. So here we go. Okay, I've got a green light. Nothing's gone bang. We've got a green here. We've got a white screen. Desktop. Fantastic. Sensational. Right. Well, I can probably throw the actual power switch this time then. Oh, maybe not. That's still very floating around. Unplug from there. Right. Let's get our GoTech out and see whether we can actually run anything. Okay, so this has proved virtually impossible, well, completely impossible to get set up and the monitor in shot at the same time. So I'm going to have to sort of like wobble from one to the other, I'm afraid. So here we are. We're connected up with our GoTech. I don't believe I've got anything on here that will actually run, but I'll just have a quick go, maybe see if GenBench will run or something. If I even have GenBench on here. So I'm powering up. I've got a green light here. The desktop is up and we've got driver A recognized. So I'm going to leave you now on the screen and we're going to have a look around and see what we can do with it. GenBench, there we go. Can't even run front bench on this. That needs 1 megabyte. Right, there we go. So GenBench 608B31. Will it work with 512K? It will. Sensational. Okay, so I'm going to do an integer division. Obviously ran from STFM. And our comparison is TOS 2.06. Yeah, okay, so that all looks normal. That's the STE, but that's absolutely fine. We should still see, 100% now on the integer division on account of this still running now at 8 megahertz by default. So if this works, oh well, I must have mixed up my firmware. It's clocking in at 195%. That's awesome. I thought I'm completely confused. I thought I had a STE08 high. Let's compare with that. I thought I had an 8 megahertz firmware on here. Well, we're there we go. Look at that. We're running at 16 megahertz. Huh. Well, that's an even better test. ST206.16, right, so it should be the same as an ST206 at 16 megahertz. Yeah, sure, 102%. Perfect. Right, well, big thumbs up. We're running at 100 at 16 megahertz. So the next thing, I need to try and work out if there's any way I can possibly get Alt-RAM working on here. Obviously TOS 1.02, which you can see here. This is what's presently installed at the moment on my my little TOS ROMs down here. This does not understand what Alt-RAM is, so we have absolutely no hope there. So the only question is whether I can build myself a copy of EmuTOS, which is small enough to run from a floppy and will set up Alt-RAM. Now with the ST series, Alt-RAM needs to be, I suppose it doesn't need to be, but if it's to be auto-detected, it has to trigger itself. It's not on by default. So what I need to now do is to go away and try and work on that, and see whether I can get RAM from Alt RAM to appear down here in GenBench, and then from that 195 we should end up at, I think, about 207 is what I see on the STE. Okay, let's get on to that. Well, just wait a moment. What's this I already had here on my Gotek drives? MUTOS 720, this says, 720K floppy, and we've got a UK version of MUTOS on here. And when I look at it, ignoring all of the dodgy files that come from my Mac, the whole shebang is only 301K. This means this MUTOS may be small enough, 278K. I think there's a good chance that we can run this. So this is just a speculative one. Let's give it a try. This will take a couple of seconds to load. So what I'm expecting to see here is, if this has been built with Alt RAM, which I think it probably will because it was destined for my STE, hopefully it will detect it, hopefully it will declare it, and then hopefully we get a desktop which actually has RAM enough to run a program. Unfortunately, it won't be front bench because I'm on a VGA monitor, but we can have it. Here we go, MUTOS 111. I'm going to press hold, Atari ST, 512K and 8 megabytes of Alt RAM with driver A. Look at that. And it thinks we're on the 5th of May, 2039. My dad's birthday. Happy birthday, Dad. You'll be approximately 1 million years old. And there we go, we've got our desktop. Right, let's have a look. So first of all, MUTOS version 111. So this is an official one. This hasn't been built specially by me. Desktop configuration, here we go. Right, so free RAM 7. Okay, I'm probably doing a special one. Free RAM 70K of ST RAM, but 8 megabytes of Alt RAM. That's well, that's amazing. Okay, so why don't we try the old GenBench again? Okay, to explain a little bit about what I've just gone and done, I should just say that from TOS 2.06 or TOS 2 onwards, where it supported the concept of Alt RAM and TTRAM, you can specify within the program file itself whether your program is capable of running or should run by preference from STRAM or from Alt RAM. The reason being, you might have some programs, older programs, that don't understand Alt RAM exists, do not know that they can't use it for writing to the screen, for setting, for example, the frame buffer from Alt RAM. So you can flag them to not run. And by default, that's how most compilers output things. And GenBench 6, the version I have here, is set up not to run from Alt RAM by preference, therefore it won't fit in memory. So you need a little program like setFlags here, which can modify these. So I've just put this on the disk, and what we should now be able to do is to indicate that GenBench is to run from Alt RAM. So here we go. So it's got the fast load flag. It's not selected that program runs on Alt RAM, and the allocates memory from Alt RAM. So I'm going to turn all those on. It also got some memory protection flags down here, but they're not relevant at the moment. And that's just changing a couple of bits right in the header of the GenBench program that is now capable of running from Alt RAM. And here we go. Right, so let's set our comparison. So we're going to compare ourselves to what have we got? Do we have any straight ST? STFM 1024 at 8. I think that's the closest we are, although obviously that's the amount of memory makes no difference. Right, and we're going to okay, I'm in high resolution mode. I'm just going to let it run a CPU test. Let's go. Okay, fantastic. There we go. So we're running from Alt RAM. Otherwise it wouldn't fit in memory because the operating system is in STRAM. We are seeing a figure of 207% on the integer division. we're running slightly over 16 megahertz. It's 16 and a third, something like that megahertz. So we would expect it. Previously, you saw it was 195%. Obviously, it's not completely. It's got to switch down, so it's never going to be completely at 2 times. But this is slightly over 2 times because now the instructions are also loading from alt RAM, which is important. RAM access and ROM access, we haven't changed anything with those in this particular build, so they're showing just over 100%. Again, that 6% comes from the fact that the instructions can load quicker. And the reason the instructions and everything else can run from load quicker from alt RAM is because our alt RAM speed is basically also 200%. We're accessing things at 7.5 megabytes a second instead of 3.5 megabytes per second. So I've got a few things that I want to do with this, but I think my first one will be to get it hooked up to the color monitor and start working on this firmware. So that's all for today. Thank you very much. Hope you found that interesting, and I'm going to declare that somewhat of a success. See you next time.